Okay, welcome back to yet again another video. This time we'll just be looking at just a quick lesson on the active buzzer. So let's go ahead and get started. It's quite simple, so it'll only be like a couple minute video. Let's go ahead and take a look at the active buzzer. Okay, so the active buzzer. First, the components you need obviously are the Arduino R3 board. You need an active buzzer, which I'll show what it looks like, but it basically just look for the sticker because that's like the main the differential, and then you need two female male wires. The female male is like this one like end with like a little pointy thingy, for lack of better words, and then one which is like hollow. I guess I can show what that looks like as well, but you should already be familiar with what a male to male jumper wire is and what a female to male DuPont wire is, but I can go ahead and show that later. Anyways, the difference between an active buzzer and a passive buzzer is that, um, as you can see here, you need to use square waves as frequencies between 2K and 5K to drive the passive buzzer. Um, so, from what I've taken away from reading this, the active buzzers are just better. Hence why they're more expensive because they have a built-in oscillating circuit. Now, do I know what this exactly means, like in a real world context? Not really. Um, I guess I'll search it up later. Uh, yeah, it's not a crazy amount of introduction. Yeah, I'll go ahead maybe like post something in the comments once I just maybe have time to research more about it. But there's other things to be done as well regarding Arduino, so this may be on the back burner. But anyways, let's go ahead and just look at the wiring schematic. Very simple. Just go ahead and use the male to female DuPont wire connected to the power source, the GND, and then connect it to pin 12. And yeah, pretty simple. Let's go ahead and like upload the code and see what happens. Uh, right here, I already have it opened up. So connected to my Arduino Uno. Let's just go ahead and walk through the code a little bit. I feel like this is kind of helpful. The pin of the buzzer is already given to us, pin 12, which is why we have to get to pin 12. Setup. The buzzer is an output. I'm not exactly sure for how setups work, 100%, but like this loop is like quite simple to understand because I know a decent amount of Java. So basically, all it's saying is that it's setting up a for loop. The sound duration is 500, which I'm pretty sure is like half a second because 5,000 should be 5 seconds. So 1,000 is 1 second. So that means 500 is half a second. I think it's measured in milliseconds. I think that makes sense. So it's basically saying the sound duration is 500 milliseconds, and the way it's set it up is like it's gonna keep or it's only gonna loop. It's gonna go through the for loop once, and then we're gonna you go ahead and see it, but it's gonna like beep slowly, then faster, then faster, and then it's gonna go back to slow because obviously the Arduino is gonna keep looping over and over and over again. That's why we have the void loop, right? And then this section basically just tells you it allows for the oscillation. So that's where you get the sound going on, the sound going off. And you'll hear that's how you get the beeping sound. And this may be like the difference between a passive and active buzzer, but I could be wrong. I actually don't know the difference like as well as I should. But anyways, yeah, that's pretty much it. And then this end section, I think is for like, it's definitely after this for loop is done. So I think it's just like an indicator to start, that starts the yeah. So basically, the beeping is going to go really really fast, and then once the loop ends, it's going to play this sound for like 5 seconds, and it's going to go back to the beginning of the loop. I'm pretty sure. Or I mean, I have tested it out. But anyways, let's go ahead and take a look. So I've already uploaded this, so no need to do that. Let's go ahead and see what happens. Okay, there we go. I'm not sure if the microphone picked it up, but it basically just did exactly what the code said it would do. So it's good that we can interpret this code now. Yeah, pretty straightforward. I might use these. these for like preliminary like testing of like of the circuitry that I'm gonna do, just to see like if the right signals are working. But to be honest, at least for like what I have like planned in my mind right now, I don't think I'll have a big usage um, for these speakers. So, oh, sorry for these buzzers. Yeah, but it's fine. Good to know. Pretty cool thing. Yeah. Oh, also cool. We were a little bit of a rebel, and instead of connecting the female male jumper wire to the GND on this side, we connected to the GND on the other side. And I mean, obviously, by logic, it should work, and it did work. So cool. We're getting a little bit more free with these now. I know I said I was gonna go ahead and investigate the power source to like the breadboard. Still trying to look at that because I'm not. I thought I had an interpretation, and then I watched like a Mark Rober video, and then I just got lost again. So I'll figure that out. In the grand scheme of things, I don't think it's going to be crazy impactful, but just for my sake, I kind of want to know. Anyways, see the next lesson, which will also be kind of short. It's just ball switch, so not too terrible. See you in the next one.